There we go. Class 5. It feels like it's been a lot longer than just like 2.5 weeks, but there we go. We're doing chapter 6, unit testing. I'll do over some examples. I will talk about the graded assignment a little bit, but not too much. And then I will give a studio intro. Again, unit testing. Not a lot of slides on this. This is just a lot of vocabulary there. The whole purpose of testing is this automated testing. I mean, a lot of people are like, yeah, we want this unit testing to see if each individual unit works. But the whole purpose we get these individual units to work is so that whenever I, as a programmer, push my code, just like you guys push your code to GitHub, and then there's the graded part of it, all those are tests. So I can come up with whatever test I need to, and whenever I deploy it, it will run those tests automatically. And if something doesn't run, I can make triggers based off of if it doesn't run, then don't deploy it, and then email a bunch of people saying that the code's bad. So all of this testing goes into automated testing. That's really the focal point that you guys should be talking about. Like if they ask you about testing in interviews, you can talk about unit testing. Everybody kind of knows what that is. Like just as a unit, like as a class, every file should have its own testing more or less. And it's just testing that one file or that one kind of process as a unit, not as a whole. Not testing the whole entire program. It's just testing individual pieces of it, units of that program. But the whole purpose of testing is really to automate it so that you feel very confident whenever you make an adjustment somewhere else in the code, it doesn't break other functionalities that are already in your code. So automating that testing, doing it unit by unit. JUnit is the kind of number one go-to for unit testing in Java. So that is a common industry practice. They did talk about like refactoring. So what they're talking about here is, remember, when we write code, sometimes our code gets really messy. We're writing like 25 lines of code, and then we're like, okay, so this works. Now I need to refactor it. One of the securities you have if you write a unit test is whenever you know your code is working and you have a test that is working, when you refactor your code to be smaller or better or more efficient, instead of you wondering, does it still work the same? If you have the right tests in place, you just rerun the test and the test will tell you if it works the same. So it helps that confidence of being able to refactor and redo things and try new things and know that it works or doesn't work. Something else, I guess where I'm at, it's not as common of a practice, but let's say that I'm looking at a piece of code. If I have a test that goes with that code and I put in my test exactly the right things I need to test, that could be better than basic documentation about what my code even does. Because if I'm looking at my test and I know that it meets these qualifications and these functions work in it, in my test, then I know that my functions have to work like that in my actual code. So instead of reading through 50 lines of code, I can just look at my test, do like an overview of what they do, and then I now know what those lines of codes do. So that's what they're talking about with documentation. Somehow, whenever you get in a code base, like my code bases are thousands of files long or files large. I still, working in a company for a year, wouldn't actually touch every single thing in that code base. So if I can look at tests, then I really don't have to look through all the code. I can just look at the tests to see what they do, to then understand, well, do I even need to look at that part, or how do I need to modify this? Again, the teams I'm on doesn't do as good test writing to be able to use it as true documentation, but some companies do. I copied and pasted the testing best practices from the course and put it on the next slide. Talking about annotations, those are the biggest ones you'll kind of see there. Whenever you test, you have to say that it's a test. Well, how do you do that? You do @test right above your test, and then Java knows that it's a test. That's like declaring it. If you do a before each, it'll rerun that section of that function before each test. And if you do an after each, it'll run it after each test. It does give a good example of before each. It like resets the car before running all the tests. So you always know you have a fresh version of a car before you run the test. You could do something with after as well. They don't give a good example, and I really haven't used that one either. I have used the before each. And then there are the three most common kind of assertions, or four. There's four there. Assert equals. I think we've done stuff like that. You put in what you're expected, and then you actually put in what the actual code that ran, and then it checks to see if it's equal. There's assert false and assert true. Those are identical. Just one is looking for false, one's looking for true. And then there's a not null option. Those are the ones that they give you out of the book. So I think we've seen the equals, the false, and the true before in our, I think in our graded assignment. Testing best practices, the AAAs of unit testing. So arranging the variables for your tests, act on the methods your test requires, and then assert the anticipated comparison. So what that really does is at the beginning of your testing package, you're going to make sure you set up all the variables that you might use in this test. On each of the methods, the bigger methods inside your class, not your setters and getters, obviously, because those are just common, those aren't going to mess up. But any custom method that you put inside of your class, you usually want to write a test for that. So you're going to act on the methods, your custom methods, and then you're going to assert the anticipated, like, here's what I expect out of it, and then you actually run the code and see if it actually compares to what you expect. I mean, you can read most of the rest of them. A test that passes most of the time is a worthless test. Like, it needs to be an all or nothing. Make sure your tests are relevant. They should be grouped. This is just clean code in general. All of your methods, even in your class, also a test, should be kind of easy to go through and sequential or understandable of kind of why they're in there. And then down at the bottom, there's no need to test trivial code like your setters and getters. Like, why are you going to write tests for those? Yeah. Before I get to these Q&A, I was going to answer some of the questions in the chat real quick. First one was, so like on a team, who should be like focusing on these tests? And it is the engineer's responsibility. So I, as somebody writing the code, it is my responsibility to write tests. The difference is sometimes I forget. Sometimes I may not write the best test. So there are two other helpers in me creating tests. One is QA. So every time my code goes somewhere, I usually have it checked by somebody else, whether that's another engineer or an actual QA engineer, a tester. And if they find anything wrong, but I think that my code is good, that's a perfect reason to put a test there. Because I thought everything was good. They saw an error. So I should probably create a test for that. And then the other one is if it does get past your QA and it gets out to production and you guys see a bug defect come back to you because somebody actually, like one of your clients has a problem, those are perfect to put tests in your test code for as well, because obviously something got missed. So those are the best ones to put in your code, not the, not the ones that are kind of trivial that probably won't ever need testing. So that's how I and my company kind of does it, and that's what I've seen most often when I've talked to other people is usually people are catching things, and when you have a problem with code, you write a test for it so that if you have a problem later, you know that it's broken. Unfortunately, QA usually does not write the test because they often are not software engineers, and they don't really know the code. They just know how the user interacts with it. I will show you how to run individual tests in IntelliJ. And then a good question, I'll have to look at it. Why does the solution put the method expected in the value of actual? To be honest, it really doesn't matter what which order they're in. Technically, if they're equal, it is common practice though to put what you expect first and then the test value afterwards. So I'll look at that whenever we get there. Now the QA questions that were asked in the Discord channel, somebody was talking about like public access modifiers, and then but we use setters and getters. So I just wanted to clear the vocabulary there. When the book says public access modifier, they are talking about setters and getters. So a public access. So all of your fields should be private. And then to get public access to those fields, you use setters and getters. So I don't know if that was the confusion, just the vocabulary or what. But if you asked that question, I did not answer it well right there. Definitely ask me again, and I have no problem answering that. But generically, fields, private. You do not do the menu item dot description. It's just not how Java works. You do menu item dot get description with parentheses because it's a function, it's a method. So there was a nice picture there with just a bunch of stuff in the console that IntelliJ does. IntelliJ will always default to telling you more information than less information. So all of that stuff is actually what it's doing. I think the first line is something like compile Java. So that's the first thing it has to do whenever you push the run button, whether you're running a test or running your program, the first thing it has to do is compile all that code. And then when it compiles all the code, then it has to make sure that it actually builds the classes. It makes sure that it builds the test. It makes sure that it does all that stuff. Does that mean that you guys have to know what all that stuff is? No. I might, I don't know if I can show my work stuff, but whenever I hit run at my work or build or install or whatever I'm doing, there's like 2,000 lines of code that run before anything happens. So, and I don't read that stuff. I mean, half of it's read too. I just don't read it. Unless if something breaks, I don't read it. So, yeah. I did not. I will have to look at that. So the question was the tests specifically, do we make them public? I've always made them public. Tests are not included in compiled code. So whenever you push your code and actually deploy it, like we deploy ours on AWS or Azure, that all the test code is not included in there. It runs the test, and then it builds all the package stuff without the test. That's another reason why you have a test folder, and then you have your Java, your main folder, and then your test folder. All that test folder stuff is good for the testing, but it is not included whenever it actually creates like the jar. The jar is like the wrapper of all your code that's already compiled. So I just do public. I don't think it really matters if it's public or private. And then also if it omits public, that usually means that I think it goes to the default of protected, so it still be open to everything it needs to. So I guess it's one of those, if you don't put public and it works, it's fine. I don't think you should make it private. I'll have to research that a little bit more. And then another question that came up was this assert throws. You kind of understand what's going on. I'll explain it again once we get into the live coding. To be honest, it really just depends on what your program does. If you do a lot of try catches with assert throws or with throwing exceptions, then your test will have assert throws in there because you're testing your code. Does the stuff that we do right now need exceptions? Probably not. We're small enough. You could write everything we're doing without using exceptions. Therefore, your test would never need assert throws. Once you get up to bigger programs and projects, I can see a benefit for that. But all that's really doing is it's looking to see if it threw that exception. And you usually put the exact exception that you're looking for there. And it's almost like an assert equals. Like assert equals says, well, what are you expecting? Well, I'm expecting it to be 32. But that's whenever I type in that, whatever value is $32 or something, and it checks to see if they're equal. The assert throws does the same type of thing of like, well, what kind of exception are you wanting it to be at the end? And then how are you wanting to get that exception? What function are you going to be calling to get that exception? So many of them are just comparisons. Checking before I. Expectations real quick. Graded assignments due next Monday. Pretty much everything you need to know there. And of course, I have itty bitty stuff here, so I'm going to make this bigger. Unit testing. Right. Oh, let me make all of it bigger. Right. So again, whenever you run a test, because I ran a test just a little bit ago, it tells you what tasks it's doing, like process resources. If you have external resources that it needs to like pull in and compile along with your code, this is where it would probably do that. It has to build all the classes. It's compiling not just the normal Java, but then your tests. Remember, those are separate things because we don't want test code going out with our actual production code. So it's going to compile the test. It's going to see if there's any resources just for the test. It's going to build the test classes, and it's actually going to run the test. And then it tells you if it's successful or failed. I was actually looking for that, so that's why it did that. Okay, with the car. Many of you, there shouldn't have been a lot of actual lines of code that you actually changed, but I just want to go over this car class. Did you see how all the fields are private? That's what we're looking for there. All these fields are private. We have a constructor that takes in make, model, size, and level. And then it assumes that the tank size is the tank level at the beginning, and then miles per gallon. It does a lot of the setters and getters. It probably did auto-generated because they're right next to each other, so the get and set are right next to each other on all of these. And then it did make a custom drive function. So this is a perfect reason to have a test. Whenever I make a car, does this drive function do what I want it to? So whenever I drive, it should make the gas level go down and then the odometer go up. So I should be able to check both the gas tank and the odometer to make sure that it did what it needed to. And then this was the added thing where, well, we usually go to the gas station and add some gas. So how about I tell it how many gallons of gas that I added, and we're going to add that to the original to my current gas tank level. And then the problem is if I have a 10-gallon tank, I technically can type in 20 here, but I can't fill up my car with 20 gallons if I only have a 10-gallon tank. So that's where it had us add this. If the tank level ever gets bigger than the size of the tank, then throw an exception. That is weird. I would not have done this. So when you're inside here, you don't have to use the getters and setters. And actually, I usually don't. I would usually do this. I don't know if that, you guys kind of saw what I did there. Yeah, whenever I'm inside here, I don't need to use the setters and getters. The setters and getters are for outside this function. I usually just use the variable I have right there. But this looks good, where once the gas level goes too high, if it's more than the size, well, how do I handle that? And you could throw an exception. So here's where some people would say, well, why don't I just print out to them level too high or something like that, right? Also, this is red because once you throw an exception, it doesn't run the line underneath it. It actually exits out of it. So I actually need to put this, if I'm going to do something, I'm going to put it above it so it actually runs. So the question is, well, why don't I just print it out? And I think the harder part, and we haven't really got into how Java and then front-end development works, but with Java, your users are not going to see the console. Anytime you print out to the console, like I actually never in my production, in my testing or anything, I never use system out print line. I am using a logger. There's a logger function that then logs to whatever logging mechanism that I am retrieving that from. And on both the teams that I was working on, that's how they always did it. So I never use system out print line in the code that I use. There's some other way that I need to do that. So again, you can't print to the console because the user doesn't use the console. So then how do you get this message to like bubble up to where the user can see it? And that's where throwing exceptions can work. When you throw an exception, that exception goes all the way up until you catch it. And if you don't catch it, it actually goes all the way up and it actually stops your program. So exceptions can go up higher levels, and that's the kind of benefit of an exception. Again, where you guys, like the level of difficulty and understanding that you guys are at, you just need to know what an exception is. So whenever you guys see it, you can kind of play with it. You don't need to be thinking about that. That's more of like a senior level person that's going to actually implement new exceptions. You just need to be able to read it and kind of know what's going on. But the reason they do an exception is, remember, my car could be, this could be a 1,000 file code that calls each other depending on what I want. And then I want this to then bubble up to where it originally got called. And that might be in 3 different locations. So I need to catch it in 3 different locations. And then I can actually make this an illegal argument, but then I can customize it to be a certain, message that I want. So, so hopefully that at least explains the system out print line will print down here whenever I run this. So if I do main, and this car dot add gas, and I do like 100, and I run this, well, that's not what I wanted. It is not liking something I'm doing. Oh, well, it'd also help if I ran in debug mode if I'm actually wanting to debug it. So this is hopefully showing you guys something. If you hit this run and you do debug and then you can set breakpoints, it'll actually stop here. So it stopped right where I was at. So it's right here on this line. And then over here on the left, I can do all my debugging. So step over. So now it made a car. If I hover over the car, it tells me all the stuff about the car. And then if I go one more, it's still printed out. If I go to console, it printed out Toyota Prius. So it did the car make and the car model, Toyota Prius. And then when I step over, this is exactly why. One thing I do get frustrated even at myself about this, whenever you do the console, it sometimes breaks it apart into all these different things here. You always need to go back to the top level to actually see all the lines. So here's where I said Toyota Prius, and this is where it says disconnected from the VM is virtual machine. Remember JVM? So there's the Java virtual machine. So it disconnected from the Java virtual machine, which is holding your code, your compiled code. And it says here level 2 high. This is what I was looking for earlier. So, and then it says that it failed, and it says the exception was an illegal argument exception, which whenever I go back here, it's a legal argument exception, can't exceed tank size. The level 2 high is from the system out print line. So that's where these things come from. I'm used to seeing these right here, this exception in thread. And if you saw, it like stopped my, it stopped my program. That's what exceptions do, unless if you do a try catch, which I'm not going to do. Yeah, the try catch, the hard part with the try catch is I don't want it to go on to the next thing. So if I did a try and then a catch, I could actually do the system out down here because I know it's actually going to run this time. So the problem with doing a try catch here is it'll still run this thing right here. So I'd have to rep this in an else. Say only do that else. It's not like this. This might work. So if I run this, do you see how there's no red? It built successfully. That's because I caught the exception. If I don't catch that exception, it does not build correctly. That's the reason you catch exceptions. But it did do what I wanted to, which was doing the level 2 high, and I custom made an exception like the message. But the key thing about the try and catch is it builds successfully. If you don't catch it, it gives you all that redness that we had before. Just so you can see that again. No try. So if I just have this without a try and I run this main method again, it's all this red. So We still haven't really talked about testing. This is great. Okay. So to get into testing, as you can see, I've avoided it a little bit. You can write tests. So this wants to have a test car. And before each test that you run down here, it's going to reinitialize. Init is initialize. It's an abbreviation that you see quite a bit. So you're going to reinitialize the car to be a new car that's this Toyota Prius. Now inside here, I can run all of them. If I click on this car test and I click on this one, I hit run. Down here, it says that there are multiple tests. These little things here, I sometimes accidentally unclick this show paths. I've seen a couple of people not click those. And so then they're like, well, where's all my tests at? So just know that here's all your tests. So you can go one by one and see what it prints out. It usually doesn't print anything out. It's usually either it passes or it fails. And then if I wanted to run one test at a time, meaning this tank after driving, if I wanted to hit this one, it would just run that one. And it says successful with the green check mark, but it only ran that one. If you saw one that failed, let's undo this thing right here. And this will fail. This one. Again, you have a lot of red. It does tell you that it threw an exception, or no, it says that it wants an exception to be thrown, but nothing was thrown. And so then, somebody asked, well, how do I kind of get in there and do that? Well, you could put a breakpoint here, but again, this is one line. Even though it looks like 3, it's only one line there. So a breakpoint here would not help you at all. But if you go into the add gas, and then set a breakpoint here, and or go into the set tank level and have a breakpoint here. Did not want to do that. And then you want to rerun this, but you want to rerun it in debugging mode. It takes a little bit to start up. Running in debugging mode does take a little bit more time to get started. But as you see, it has my red point right here. It says this, and it tells me these are all the threads. This is the, oh man, I forgot. The thread queue, that's not the right word, the vocabulary for it. But this is the all the stuff that is called to get here. So that right now it's at the add gas, and once it actually fixes this, then it'll go to this one and it'll go to this one. So these are the ones that called it beforehand, and it's waiting for it. If I go to this is the car that I'm currently in, which is the Toyota Prius. If I step into, it'll ask me, do you want to step into getting the gas tank level, or do you want to step into setting the gas tank level? I want to step into that one. So now it's here, and it tells me that my gas tank level is 15. It tells me my gas tank size is 10, so 15 is greater than 10. So I know that if I step over, it's going to go to this line. It's going to keep going. And then it's going to actually set the gas tank level to B. So now it incorrectly, because remember I got rid of this throw exception, it now says that the tank level is 15. When I think the max, when I go to this, yeah, the tank size is only 10, but it says that the gas tank level is 15. So yeah, definitely play around clicking those buttons. You'll learn a lot more just by clicking them. Oh, I just reran it. I wanted to, there we go. And there's my test failed again. I don't like failing tests, so I'm gonna uncomment that. Fine. Stack trace, there you go. That is the correct definition there. It's your stack, technically. So that's your stack, and then you can trace it by actually going through it. Fine. Again, I don't know if there was a lot of stuff in here, so I'm looking for you guys to figure out if there's something else with these cars that I need to do. But I mean, I do have other stuff I want to show you, but not with testing specifically. So right. I can always come back to this, but I'm going to clear these out. I'm going to go to, again, the studio, not because of the exact studio, more for, I want to show you a couple things that I was playing around with. I will let you know I stole this from somebody's group originally, and then I've been modifying it a little bit. So just so you remember, whenever you did the studio, you should have had some menu items. You created, I did lunch items just because this array list, and then I added the 4 menu items into this, and then I made a new menu with a new date, does today's date. So you can do that real quick, or I could have put a date in there, and then I threw in the lunch items to the menu. And there could have been other things. I have seen other people put a menu title. I've seen, you can do whatever you want to, but I think I kept the menu and the menu item identical to how they did it, so that I didn't have to figure out which custom anything I was doing. So menu and menu item was by default, and then just the restaurant part here, which is, I think some people just kept it as main. I changed mine to restaurant. I did this. So some things that were asked of us was to potentially add an item. So let's say that I wanted to add a new menu item, but in my menu, I don't have an add item. So let's go to my menu, and I want to be able to add an item. Because these are just setters and getters by default, I'm just going to push them down to the bottom so that I have a little bit of room here, and I'm going to do a public add item, and then the type of remember we have to type everything, and then I usually just use the same name, and then I want to add it to my array list, which is called items. So I just do add a menu item. I need to put what it returns. I don't need it to return anything, so I'm going to put void. I like how IntelliJ tells me. Yeah, I don't know why it said that one, but now I have my restaurant. Now my add item works. But then whenever I actually print out my lunch menu, it does not print out the way that I want it to. It says menu item, menu item, menu item. So it tells me that there's menu items. It does tell me that the second one has an extra menu item. So I like that, but I want to know what's going on there. So I'm going to go to my menu item, and I'm just going to do that generate code. And I'm going to do the toString. And sure, everything can be in there. That's fine. And then I'm going to rerun this. And now when it prints menu item, because menu item has a toString method, it should print out what they are. So this says menu item, and it says price, and it says description, and it says main course, and it says is new is false. So I want to make that look better. I don't care that it says menu item. Actually, I don't like that my menu item doesn't have a name. I'm going to say private string. And this does play into what I'm going to show you later anyway. So name. Well, whenever I do name here, that probably means that I want to actually add the name to the constructor. There's a couple different ways to do this. I can say, hey, do a public menu item, and I'm going to use generate code. Why am I typing all this stuff out? Let's do a constructor that does all of it. All right. So now this has a name, price, description, category is new. But the problem is I didn't create any menu items like this. Fast way to figure out, do I have any that I don't like? I can actually just delete this and look for all the wonderful errors. So whenever I go here, you see all of these errors. There's 15 errors right here. So I'm just going to make a casserole be the name. I'm going to have chicken pasta be the name. I'm going to have chocolate cake be the name. I have 3 more errors. Oh, that's because my new one, new item. Do all right, something like that. So no more errors. I like that. I'll get back to this hash map. I can delete it for now. All right, so let's run this thing again. Oh, no, I wanted to change the 2. Hold on. Why does it say? Oh, that's my tests. Let's just comment out my test for now. I was going to write a test. If we have time, this is something that I was going to show you, that you can write tests for almost anything. Let's go back to restaurant. Menu item, toString. What I want to do here, I'm going to redo the toString and generate it with all of that. I don't care about okay. Let's see what this looks like. So it says name is casserole, price 15, description casserole, category main course. The thing I cared about is my nachos are in that one. So here's the other problem. Whenever I print the get items, do you see how the get items is an array? Right? It's an array list. So what I could do could do a print items and then do a for each menu item in my items. So for each of these, I'm going to print them out individually. And then I'm also going to do like a something like that. So I'm going to print menu items. I'm going to actually print them out each line by line. And then I'm going to have an extra line at the end. That's what this is. So instead of doing this, I'm going to say lunch menu dot print items. Let's see what this does. right? You can see the difference because I have a print menu get items, which is all an array. And then I also have a menu items, and I can change however I want to change that. I have an extra bracket at the end. I don't want to do that. Right. So you can see that. Now let's start talking about adding and removing. So I think I figured out how to add it. I just do, I've already added one. Add item. So add item just adds it. So when we're talking about overloading, let's talk about removing items, because this is where it gets a little interesting. How do I remove an item? Well, I think the easiest way is to just pass in the menu item. And then I do something like items dot remove menu item. I think that might be easy enough. So when I do something like this, this is going to remove the egg roll. And then I'm going to actually comment those out. So now the only thing I've changed, I've added the 4 things here, and then I'm going to print out them, and then I'm going to remove the egg roll, and then I'm going to print the items again, and there should not be an egg roll. And again, this should not be something like, oh, this is so amazing. It's still, so the original one had the casserole, and it had the egg roll. Why don't I just change how to print that? Hold on. Click on that. So this one has the casserole, chicken pasta, chocolate cake, and egg roll, and this one has no egg roll. That's great. Now, here's the problem with code. We, doing a runner class, it's very easy to grab the thing that we just added. But when we're talking about users, users will not be able to just pick up all the stuff in the object. They might be able to figure out, well, I want to remove the 4th item in there. Okay, so we can, instead of removing egg roll, what I want to do is I want to remove the 4th item, which, well, let's remove the chocolate cake. That's 0, 1, 2. That's the index of 2. So I can go back to menu, and I say, I want to remove item. But here's what the question was, should I already have a remove item. I could say remove item by menu item. I could say that. But if it's by menu item, well, it tells me right here, it's a menu item that I have to do. So this is redundant. On the other hand, if I want to remove item by, let's say, an index, the index number, then I can still do remove by the index. And now, if let's say that I wanted to, like I said, the index of 2. Do you see how on here it says index? Is it gonna? Oh, it doesn't. I thought it would show you kind of like this one does with index. It would say menu item, but it doesn't. So I want to remove. Oh, that's remove. That's not what I want. Remove item. That's why it showed it to me. Right. Remove item 2. So remember 0, 1, 2. This should remove the chocolate cake. We do not have chocolate cake anymore. And again, this is overloading methods. I want to remove this item. I want to remove this item, but sometimes I don't know what's exactly getting passed in. Well, to be honest, when I really want to remove items from if a user wants to remove items, They don't want to have to memorize an index. They don't want to have to memorize a menu item as a object. They want to know, they're just going to type the name of it. So menu item name. So they're going to type in something like, instead of 2, we know that one of the names is casserole. So they want to just type in casserole to remove it. Now that is a little harder. We can't just remove it based off of index. I know my little cheat sheet here says remove. So I can remove an object, which is the menu item object. I can remove based off index. Those are built in. You can do this one. I usually copy and paste that one too, so I don't really use that as much. So I'm going to teach you the old-fashioned way. What we're going to do is we're going to do a for each loop, and we're going to do for each menu item in my items. We're going to iterate over all of them, and we're going to say, hey, if that menu item dot, no, not menu, yes, menu item, I can't get anything. That's because there's no getters in here. They only have setters. They don't have getters. So let me put those in real quick. There we go. That's going to make my job a lot easier. So here's the big difference. You know how normally I would say something like name here. I can't do that because I am in the menu class trying to access something inside the menu item class. So I do have to use the get name here. You can't just say the name because I'm in a different class. But I'm going to say if that dot equals the menu item name, then I'm going to do an items dot remove menu item. So this is just the good old-fashioned search through all the items, and then if the menu item name, the string that they passed in, is the same as the name of the actual menu item, if that equals, then remove that menu item. So hopefully I copied and pasted that. So now this time it should remove the casserole. And it says that, no, it hates that. It says when it tried to remove the item, it could not do that. Now, here's the kind of weird thing. Whenever you do this concurrent modification, that means I am trying to remove an item as I am trying to use the list. So I can't do that. This is all the kind of weird stuff that whenever you think in software development, whenever the business people come to you and say, oh, can you do this small little ask for me? And you're like, yeah, I think I can do that. And they're like, well, how long is it going to take you? You always tell them twice as long as what you originally think, because you run across things like this. As you guys have learned through learning, you assume something and then it doesn't work out the same way. That's how real life is with engineering. So there's a little plug in there for you to always overestimate how long it's going to take. But this says that you can't concurrently modify. I cannot remove a list while I'm iterating through it. So what I need to do is I need to save it and then remove it afterwards. So I want to do, I do need to remove this. But what I'm going to do is I'm going to have a menu item called menu item. I'm probably going to make it null at first, not menu item. Menu item to remove. There we go, a better name there. And I'm going to set menu item to remove equal to the menu item. And then I'm going to say if, okay, I'm going to do this incorrectly so I can show you some more bad things that I've seen before. Okay, so I do think that this will work. You could do a break. It's a good idea. This will break the loop so it doesn't keep going after it already found something. I like that. So let's rerun this. Oh, and if you look, casserole, there's no casserole. So it liked this. But then this is where testing comes in. What if my user doesn't know how to spell? And I don't even know if I would have normally spelled this with one S or two, because I really don't know how to spell casserole without copying and pasting it. But let's say that they spelled casserole with only one S instead of two. Let's see what would happen there. It did not delete it. So it is very much case sensitive. And it's very much, I think it might have been this. I'm wondering how, yes. Well, it tells you that. IntelliJ is so smart. The other thing that I have seen in common errors is something similar to what I have here, where you set something to be null and then you reset it. But then what happens whenever this, it goes down here and you might have a null pointer exception. I guess they have built inside the remove, if object is null, so they have this object is null kind of catch in there. Not all methods do that. Anyway, I was hoping that it would actually throw a null pointer exception, and then what you would do is you would do an if menu item to remove does not equal null. Then you actually remove it. So oftentimes you have to put a null pointer exception. If you ever see a null pointer, like a null pointer exception down here, it's usually because you need to do something like this. Yes, Go developer, yes. I love Go, but when you develop in Go, every time you make a method, the next line is if it's not null, keep going. But if it is null, or if there's no error, actually it isn't the null, it's the error. After every method, you have to see if there's an error coming back. Hopefully, this at least helped thought process. I don't know if it really helped with a lot of what you're originally asking for, but this is the overloading method. I promised that I would try to come up with an example, and I think this is a perfect example from the studio where somebody can remove items from different types, and it just knows which one. You cannot have both of these be the same type. Like I could not do an int index and then like an int, something else. So it does have to have unique types. We're getting close, just close enough that I want to go over the graded assignment and then I think let you out of here. So definitely if you have any more questions, I haven't seen too many. Definitely ask them. I'm not going to exit out. I'm just going to minimize it so I can bring it back. What I did want to show. First thing I wanted to show was running this tech jobs. When I run this tech jobs, and somebody already pointed it out before, but let's say that I think my code is right, but it fails all these things. If I go and actually click, that's why I like these things right here. I click on it and it says expected this, and then there's always this thing in blue that says click to see difference. And it actually shows you what the difference is. So this one says that it wants 5, but it only put 4 there. And this one has 5 and it only has 3 there. I purposely messed that up so you guys can see this, this thing there. So if you didn't see the click to see difference, definitely do that. And this is how I got my print function to work. Again, the other thing you can do is actually go, I have good code, so I'm not going to show it in here, but you can go to like your job data or your tech jobs and submit a breakpoint where you think your code is. And then when you run your test, you can just run it in debug mode. And when it gets there, it'll actually show you all of the variables. So right here, it says output and expected and input. So I can actually go to output. And then over here, if you hit view, it'll actually pop up with the view here of how it looks. So using the debugger. Now, of course, this is after it's already ran. If you want to do it while it's running, that's when you set your breakpoints inside your program and hit the debugger, and it'll stop inside your program. But again, my code is good, and I'm not going to show that in front of you guys. So. Are you guys calling this a turtle? I don't know. Oh, the background. I do have this on a rant. We're getting off. Anyway, keep asking questions. I can get off task really fast. But yes, these are random, so you'll see a different background every day. Anyway, I'll give you just a couple more seconds to ask a question. Otherwise, I'm going to at least stop the recording.